So welcome back. So now we are going to stepping into one of the most powerful pattern in the DSA, sliding window protocol or sliding window pattern. It's a pattern where most of the student or developers usually struggle, but I'm going to present it in such a way so that it become one of the easiest. Okay. So till now we were using two pointers to move across the array, and we are going to learn a pattern where we don't just move two pointers, we are going to talk about a range of values. So suppose some array is there, so I'm going to talk about this particular window. I call it window, then this is also a window, then this is also a window. Okay, so now we are going to learn a pattern where we don't just move the pointers, we maintain a window of data. We are going to maintain a window of data. So instead of looking at one element like two pointers, we are going to look at the group of elements now. Correct? We are going to do operations based on the group of elements. Correct? Okay. So what is sliding window? Let's understand it. What is sliding window? Correct? So imagine, just let's take one example. Suppose we are having one array like something number 1 2 3 6 4 5. Okay, we know that in two pointer there is one left element, there is one right pointer, right? So if I ask you, if you group the element from left to right group, so I am going to talk about these three elements, right? 6 is here. So I am going to call a group of elements, and also this is same as subarray. Subarray is, what is subarray? Subarray is nothing but it's a contiguous set of element in a given array where order is maintained, right? So this represent a array, subarray. Okay, so why do we need sliding window? This is the question usually comes in a mind. So if you see here, without sliding window, if you want to check how many subarrays we are having for a given array, what you are going to do, you are going to take one element, then you are going to pair with all rest of element, then you're going to pick the second element, then you're going to make a pair with rest of the element, then third, then fourth. You have to go until to the last element, right? So what will be the time complexity for this? Order of n square, right? For each element you are going to scan the whole array. But with a sliding window, this will become order of n. Now you can understand how much powerful it is. Okay, so there are multiple types of sliding window. One is the fixed size and another is a variable size, right? So in fixed size, what happens? Maximum sum of the subarray of size k, like this kind of example. So window size, we call it window size. Window size is fixed or constant. So question will be like maximum sum of a subarray of a given size k. Okay, it means in a given array, can you find out the maximum sum of any three elements which is having the maximum sum array. Okay, now coming to variable. So in variable, what happened? Your window, as per the condition, sometime going to shrink, some is going to expand. So what happened here? Shrink or grows. So suppose if I ask you, can you find out the longest substring without repeat character? So you will continuously increasing your subarray until you find the character which is already scanned or already present in the previous elements. If you're not getting any repeating character, you will keep on increasing this window size, right? Because you want to find out the longest substring. So in this kind of cases, we use variable size of this window size, window patterns. So window sliding patterns, there are two types again. It's a fixed one and variable. Fixed means it's a kind of slide, fixed size of window you're having, so you're going to just slide the window. So in a given array, you suppose window size is 2, so you're going to take these two elements in one window, then you are going to move the next two element, then you are going to move to the next element. It will continue to do this. So this is fixed size, okay, window sliding protocol. Okay, in the same way variable. So in this variable, what we are going to do, I told you in this example, your window will keep on increasing unless until some condition got met. Other if condition is met, then you are going to shrink, means you are going to move your left pointer to here now. So this is called shrinking. This is shrinking, this is increasing or grows. So we expand the window to include the element. Of course, we expand the window to include the element and shrink it when condition is going to be broken. Okay, so now let's show you the pseudocode for this. So let me talk about the fixed size first. So in fixed size, what are you going to fix size? Your window length is fixed and you are just going to slide the window, right? So suppose in an array you are having one right pointer which is here, and size I have taken suppose k. Okay, size equal to k, and suppose for me, for example, suppose k equal to 2. So your right side, your right element is header, which is nothing but a window size of k. I don't know like how many elements are there, but it's size of k, right? So the pseudocode will be like that. For each right, okay, you are going to add nums right. So for each element you are going to add, and you are keep on adding until if window dot size become k. If you reach the maximum size, then what I'm going to do, whatever you want to do, process the result and then remove the left pointer. Okay, so what I'm going to do, if window size equal to k, suppose you want to do some operation like process element, and after that what you're going to do, your work is done. Now again you have to move the window towards the right. So if you are going to increase the right only, then size will become k+1. So you have to shrink and from the left side we have to remove this element also, that is in window it is here, because I am going to move both thing here. So this element is going to be removed from the window. So how to remove, I'm going to write some logic to remove nums left pointer and left ++, correct? So this is the pseudocode for this fixed size, correct? In the same way, I'm going to do this for variable window. So what I'm going to do this, for this again the same loop, for each right, right pointer wherever it is, I'm going to add this element into the nums array. Okay, now here you have to check while you are having some condition like max sum. Okay, so you are calculating the sum. If your condition is invalid, then you are going to remove the element from left side. Okay, simply. So what I'm going to remove your nums left element and left ++. After that, if your condition is valid, then what would you have to simply update the result. Okay, okay. So now suppose there may be a chance, what I feel, if you're not able to understand this part, so let me show one example so that it will become more clear. So for now I'm going to give some pseudo, some dummy demo for this this particular type, and then I'm going to do the variable window. Okay, so let me now start with the problem 1, and that problem is for the fixed window, right? So I'm just taking one example, one case. Suppose what I have to do, I have to find out the maximum sum subarray of size k. Question is that maximum sum among all the subarray of size k. Okay, so what I want to do, like suppose we are having some array 2 1 5 1 3 2 and window size k equal to 3. It means you have to pick every 3 element, okay, and you have to find out the sum, and sum 1, sum 2, sum 3, sum 4, and whoever the sum is the maximum, you have to return that result. Okay, simple. Okay, so let's do that. So let me talk here of window 1. I'm writing because here we are going to talk about the window 1. So what is the window 1 for me? This 3. So 2 comma 1 comma 5. What is the sum of it? 8. Okay, now I'm going to do the slide now. So in slide means I'm going to increase the left pointer and leave this 2. A real left is here, right is here, right? So I'm going to increase the left and right both. So what I'm doing, I'm going to remove 2 and add next element, that is this one, and add 1. So my new window will become 1 5 1, correct? Now what is the sum now? 7, right? Then again I'm going to do one more slide. So now my right will come here, and I'm going to remove this 1 also. So what will happen now? It will become, I'm going to, let me write here, I'm going to remove 1 and add 3, right? 3 is there, right? So my new window will become 5 comma 1 comma 3, right? Let me small it. So 5 1 3. So this will give you 9. Okay, now coming to next slide. So in next slide, what is happening? I am going to remove 5 and add the next element, right? So next element is 2. So I'm going to do remove 5 and add 2. So this will become, new window will become 1 comma 3 comma 2, and this sum is 6. So what should be the answer? I have got all the sum. My sum is here 8 7 9 6. Which one is max? My answer will be 9. Okay, this is the answer. Okay, now coming to the now you have understood like how the fixed size sum and window size sum, how we are sliding the window to find out the next operation, right? Now coming to second type of problem, that is variable window. Okay, so let's take one question for this. So my question is that I'm going to find out longest substring without repeating character. Okay, let me explain this problem. So what I'm saying, suppose we are having one element, one string like a b c, a b c, b b. Okay, so what I'm going to do, let's take the first example. Because it's a variable, there is no window size. A is having variable, no, so that is okay. Now I'm taking the next element, I'm expanding here, remember, so it will become now ab. Repeating character is there, no, I have to find out non-repeating character without repeating. Okay, so this string is okay. So till now this is the maximum. Let's take next one, abc, I'm expanding, this is also okay because there is no repeating character. Now I'm going to take the fourth element, abca. Now what is happening, this a is getting repeated. I mean duplicate a I found, so I'm going to do the operation shrink. Shrink means I'm going to leave the first element. Okay, so in this way it is going to run, right? So let's do some run for this. So hope you are able to find out like how this window shrink and expand is happening. So whenever a repeating, in this particular case, whenever repeating character is coming, I'm going to shrink the window, and then now this is the element which is unique. Again I will take suppose next element, so what will become now, b c a b b. What will happen now, again it is going to shrink, I'm going to leave b, so my string is now c a b. Now let's take this b, no sorry, c is there, so again c is I'm going to add, then c is again repeating, I'm going to remove this c, this will become a b c. Now coming to next b, if I'm going to add b, then again it is repeating, so it will become a b c b. So again I'm going to remove the first element. So removing the first element, still duplicacy is there, yes, I'm going to remove the second one. Now it will become cb. Now this is unique, right? So and now in the last also I'm having b, so again c b b, b is repeating, so what I have to do, I have to find shrink it. Again I'm going to shrink to remove the c, then bb is left, bb is also having duplicate, again I'm going to shrink this to b. So in this way I have found out multiple combinations. So what it is asking, longest substring. So which one is the longest substring that is having no repeating character? Tell me. ABC, right? Hope this makes sense and you understood like how the variable size window used to work. Okay, it's a very important concept and I think you should practice a lot of this. Also I'm going to show you a lot of things on this, lot of variation, a lot of problems on this to solve. So hopefully this is going to help. Okay, so now what I'm going to do, we are going to write a Java code for these two operations. Okay, then we start doing the problem. Okay, next, see you in the next lecture now.